Hey, coming back with another video. This one we're going to look at multiplication. And actually this is probably my favorite of the four operations with whole numbers because there's a ton of stuff you can do and it's actually pretty cool and you can really use numbers that you like in lots of different ways. So basically this is all built around this thing called the distributive property, which sounds pretty fancy, but it's really not that complicated. So let's take 9 times 6. So 9 times 6 equals, we don't know yet. But what's cool is it's basically, in some of the younger grades, you might have learned something like groups of. So it's like saying 9 groups of 6. So we can sort of imagine those, existing as 9 groups. There's my 9 groups. And each side we have, 6 things. I'm just doing 6 dots. I'm not counting, but let's pretend that's 9 groups of 6. So that's the idea, right? Well, the distributive property says that if you can break that up into other things, it's still going to work. So let's say I'm really good with my 5 times table. I'm really good with 5s. So I wish I had 5 groups of 6 instead. I can do that, and that makes sense. I'm taking care of 5 of these groups. So let's say maybe these 5. So I can use 5 times 6 as a fact I know, which is 30, as long as I take care of those other groups. Well, how many other groups? Well, I can count 4, and that makes sense because our 9 is 5 plus 4. So as long as I account for all my groups in some way, then I'm okay. Right? And if I know 4 times 6 is 24, so I'm good to go because that's going to be giving me my 54. So even if you're not good with one of your times tables, let's say I'm not good with my 9s, then that's okay. Now, of course, since I'm good with my 5s, I could have done it the other way. I could have just said, instead of it being 9 times 6, I could have made it 9 times 5, which is 45. And then since I was supposed to have 6 groups of 9, I've only got 5, well then I need one more group of 9, and that gives me my 6 right there. Right? And I add that on, I get my 54. So that's the distributive property, and it's going to make all this happen. And the key is, as long as you're counting for all your groups, you're good. So I can see I've got my 6 groups of 9, which was the question. I just kind of flipped the numbers. Up here, 9 groups of 6, and I had my 9 groups of 6 right there because I had 5 groups and 4 groups. So as long as you account for everything, then you are good, okay? So that's the distributive property. And here I was using 5s. I was really trying to get 5s. But a lot of the time you work with 10s. So I can show you another example of that. Let's say I had, like 12 times 11. And I'm trying to figure out what that is. And those are pretty big numbers. And generally people aren't really good with their 12 times tables or 11 times tables unless it's like 11 times 4 or something like that. But for kind of bigger numbers, these 2 digits or 3 digits, people aren't usually too good with that. So they say, I wish it was 10 because 10s are so easy. So you do the same thing, distributive property again. I say 12 times 10, that's what I wish it was. And that's 120. And if you're not sure, you could just count by 10. 12 times, right? 10, 20, 30, until you get 12 times to 120. Or maybe you know that 10 times 10 is 100, and then 2 more 10s is 20. Whatever. Okay, so I'm up to 120, but I've only taken care of 10 groups. So I need one more 12, one more group of 12. And that gives me my 11. I throw in my last 12, and that's 132. Okay? So this is a really cool method because you can change any number you want, and you generally just try to make numbers that are good for you. And that's usually like 10s or 5s. But if you're really good with 7s, then do 7s. That's what's really cool about this strategy. So next up, we're going to look at an array. An array is basically just kind of a more organized way of using this distributive property. So let's do, let's do 13 times 9. And we're going to put that in an array. So the first thing you want to do with your array is you're basically making almost like a little table here. And I like to put the multiplication symbol up top because we're actually going to use an array to divide later as well. So now I'm going to put my numbers here. So I'm going to probably leave my 9 alone. I usually leave one number alone. You can break it up, but I'm going to leave the 9 here. And you can put it on the top too. It really doesn't matter. Now with a 13, I'm going to break it up into 10 and 3. So I'm going to put 10 here plus 3. So I've still accounted for my 13. My 9's right there. Everything is okay. So I've got 13 as a 10 and a 3 times 9. So now I just do my multiplication. 9 times 10 is 90, and 9 times 3 is 27. And you can add those together any way you like. Some people like to write it in the standard algorithm on the side. That's fine. Other people just like to kind of loop it together and add it that way. Whatever you do is fine, but it adds up being 117. You just kind of circle it. So 13 times 9 is 117. And I proved that using my array, which is pretty cool. So that's an array, and it works with any number. You can do, oh, let's do one. So let's do 126 times, I don't even want to do 13. Let's do it. So you can do the same thing. So you build your array, and I always like to put my multiplication symbol there. Sometimes I like to do kind of a double line or a thicker line, some way that you kind of know, because once you get lots of boxes in here, it can be kind of tricky to keep track of. But let's do it like that. So for my 126, I'm going to make it 100. I'm going to make it 20, and I'm going to make it 6. However, if you're not great at this, you could do 100, 10, 10, 5, and 1. I mean, you could do whatever you want. As long as you account for all 126, then you're okay. And my 13, I'm going to do the same thing. I'm just going to do place value, so 10 and a 3. Okay? Now you can see I've got 1, 2, 3, 4, 5, 6 boxes that I'm going to add up. Some people like to add their lines. It's up to you, really. As long as you account for everything, then you're cool. So 100 times 10, that's like 10 hundreds, which is 1,000. And go 10 times 20, and that's 200. And if you're not sure, again, you could count by 20s 10 times, 20, 40, 60. You can go up like that, whatever works for you. Now 10 times 6 is 60. Now 3 times 100 is 300. 3 times 20 is 60, and 3 times 6 is 18. So you can see the advantage of this is I'm always doing easy numbers to multiply. It's always 10s, 120s. These are always easy numbers, and then 3s and 6 are single digits, so not too hard. Now comes the hardest part, believe it or not, is the addition. And it's really just adding up your bits, and you can do it any way you want. Like I say, some people are going to standard algorithm on this side and blah, 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 blah. I usually just add up in chunks. So I say, okay, I'm going to leave 1,000, and then I got 500 right here. I'm going to cross them out, and I'm going to put 500, so don't forget it. I got two 60s, that's 120, and I've got my 18. That makes it a lot easier to add it up. So I got 1,500, right, because that's 1,000 plus the 500, plus another 120, that's going to give me 1,620, and I've kind of taken care of all that, and all I've got left is my 18, which would give me 1,638. But again, if you can't keep track of that, then add it this way, right? So 1,300, 200, 60, 60, 18. For me, I generally make a mistake adding all that together, but you could if you want. And that's our answer. So even with really complicated numbers like this, an array is still pretty cool. I'm going to show you two more methods here. They're very similar to the array, just with a little twist. So one is called an area model. And an area model means, like if you had 12 times 10, let's just say, then you would actually build this kind of model. You can imagine one of these 10 rods, and then you'd have 2 of the single rods, right? And I'm talking about, these place value blocks where you have the 1,000 block, right? And then you have the 100 flat, and then you have the 10 rod, and you have the ones. So here's the 10, and there's the 2, so that's my 12. And then on the other side of this array, or this area model, I've got another 10 rod and nothing else. And then you can imagine actually building, 100 flat out of that 10 times 10, and then 2 of the rods. So it's really like an array as well, except you're multiplying by area. So you're using those place value blocks. And you can see that it's 100 and the 20, so it's 120. Which is kind of a cool model, but it takes like a super long time to draw those bricks, those blocks, or to actually use real blocks. It's a great way to learn in grade 3 or 4, but for grade 5 or 6, you could kind of draw it. And then here's my personal favorite. So you take the array, and you take this area model, and you kind of combine them. So let's do, I don't know, let's do 26 times 13. So now I'm going to do this sort of this hybrid, this combination model. And here's what I mean by that. So I'm going to make my array, and I'm going to say I'm multiplying, and I'm going to use my 20. I'm going to write 20 here, and I'm going to write 6 here. And I'm going to leave like a lot of space for my 20 and a smaller space for my 6. Now I'm not like measuring it out so that I make sure it's exactly perfect, but you can kind of see that the 20 is kind of 20 big and the 6 is kind of 6 big, maybe a little too big, but you get my idea. So now my 10 is going to be here, and I'm taking the 10 from the 13, and it's kind of like, you know, half the size of the 20, and it's bigger than the 6. It's not like exact, but it's kind of a hybrid. Now my 3, since it's about half the size of the 6, is about that big. Alright, so it's not perfect, I'm not getting out a ruler, but it just kind of lets you keep track of how big things are. And then here's 200, because that's 20 times 10, and it kind of looks like 200. I mean, you can imagine if I kind of split it in half here, it kind of looks like 2 flats, right? This is 60, and again, it kind of looks like you could fit, you know, 6 of those rods inside there. And then this is going to be another 60, and it's, even though it's not the same shape box, it takes up about the same area, the same size. And then this is going to be my 18. And again, I just add those all up. So 200 plus these, I'm going to put those together to make 120. So that's 320 plus my 18 is 338. Okay, so that's a hybrid. So I recommend, you know, you can kind of start with this area model with the place value blocks and then kind of move your way into this hybrid, which I think is a great model because it lets you keep track of how big numbers are really easily, and you don't make a mistake where maybe you say, okay, 10 times 20 and you write 2,000, or you write 20 by mistake, you kind of forget that 0. It kind of lets you see that, you know, here's 60, so the 200 is much bigger, but not humongous, where 2,000 would be a much bigger box, right? And then once you're kind of good with those models, you can kind of shift into this. It's just called an open array. And it's kind of the, you know, the hardest array to imagine because, you know, 60 and 200 have the kind of the same size box, and 18 is the same size box as 16, where they're not the same size number, obviously. But that's kind of the end goal. So I hope you like arrays. We're going to do a lot of practice with arrays because they're awesome, first of all, but also because we're going to use division in arrays, which is a much more number-friendly way to do division than, you know, stacking up that huge long division algorithm, which is crazy. You can also multiply anything in an array. You can multiply decimals, fractions. You can put negative numbers in them. You can do a lot with arrays. That's why they're so cool. So yeah, hope you liked the video. Try it out, and let's see how it goes.